Hello friends, welcome to Easy Maths. In this tutorial, we are going to discuss about the fundamentals of sequences and series. Before getting started, let's ask ourselves two questions. So, what do we already know about sequences and series, and where can we use them in the real world? To get the answers for these questions, let's get into the lesson. So, the main objectives of this lesson: the idea of sequence, the sum of first n term of a series. The idea of sequence. In mathematics, a sequence is an ordered list of objects or events. Like a set, it contains members, also called elements or terms. And the number of terms, possibly infinite, is called the length of a sequence. Unlike a set, order matters and the exact same elements can appear multiple times at different positions in the sequence. For example, 2, 4, 6, 8, 10, and so on. So these terms get increased by 2. 0, -5, -10, -15, -20, and so on. So these terms are getting reduced by 5 each time. So the next sequence, 1 half, 1 by 2 squared, 1 by 2 cubed, 1 by 2 to the power 4, and so on. So if you notice, it is multiplied by 1 half each time. So we'll be discussing more about these types of sequences in our next videos as well. So we denote this sequence by A1, A2, A3, and so on, and the general term or the nth term of the sequence by An. So let's have an example. Write down the first three terms of the sequence in which the general term is An equals to n squared. If n equals 1, then A1 equals 1 squared equals 1. If n equals 2, then A2 equals 2 squared equals 4. If n equals 3, then A3 equals 3 squared equals 9. Increasing sequences. Consider the sequence 0, 5, 10, 15, and 20. So in this sequence, each succeeding term is larger than the previous term. So the next term, 5, is greater than 0, and so on. The sequence A1, A2, A3 is said to be increasing if An is less than An plus 1 for all n equals 1, 2, 3, and so on. So An plus 1 is the next term to An. So if you add 1 with the n, you'll be getting the next term. And that's what we call as increasing sequences. Decreasing sequences. Consider the half 1 over 2 squared, 1 over 2 cubed, and 1 over 2 to the power 4, and so on sequence. Here each succeeding term is smaller than the previous term. So if you notice that 1 over 2 squared is smaller than 1 half. The sequence A1, A2, A3, and so on is said to be decreasing if An is greater than An plus 1 for all n equals 1, 2, 3, and so on. So the previous term is always greater than the next term. So that's how we get the decreasing sequences. So let's move on to the next part. The sum of first n term of a series. The sum of terms of a sequence is a series. More precisely, if x1, x2, x3 is a sequence, one may consider the sequence of partial sums s1, s2, s3 with Sn equals to a1 plus a2 plus a3 plus an. So Sn represents the sum of the terms up to nth term. Similarly, S1 equals to the sum of the first term, so which means actually the first term. and S2 equals to the sum of the first two terms, and so on. So this can be written in a compact form using a summation notation or sigma notation. We use the capital Greek letter sigma to denote the sum. So Sn equals to sum of ai, where I goes from 1 to n. So the letter I indicates that we start adding from I equals 1 and end with I equals n. Formally, this pair of sequences comprises the series with the terms x1, x2, x3, which is denoted as sigma of xi, where I goes from 1 to infinity. If the sequence of partial sums is convergent, only also uses the infinite sum notation for its limit. So we'll be discussing more about convergent and divergent series in our upcoming videos. And that's it for the sum of first n term of a series. And if we consider some example, the first says sigma of I squared, where I goes from 1 to 4. So we add the values for I, substituting 1 to 4. So 1 squared plus 2 squared plus 3 squared plus 4 squared equals to 1 plus 4 plus 9 plus 16, which equals to 30. So the second says sigma of 2j by j plus 1, where j goes from 2 to 4. So this time we are going to substitute numbers starting from 2 to 4. So each time in 2j by j plus 1, we are substituting 2 instead of j. So 2 times 2 by 2 plus 1 plus 2 times 3 by 3 plus 1 plus 2 times 4 over 4 plus 1. So if you simplify, you'll be getting 4 by 3 plus 6 by 4 plus 8 by 5. And you can get your final answer by simplifying that calculation. So that would give you 133 by 30, which equals to 4 and 13 over 30. So if you notice the third example, sigma of 1 over I, where I goes from 1 to infinity. So this sequence has no end until you reach infinity. So you can write down any number of terms up to infinity for this sequence. So that's it for this tutorial, friends. So for all of that and more, I will see you in the next video. If you like this video, press the like button, and your comments are always welcome in the comments, and also subscribe to this channel. Thanks for watching.